Aloha class, here we go in section 9.4. We got 2 sections left. All right, I'm going to try to keep this one under 30 because I need you up to date on 9.1, 9.2, and 9.3. All those worksheets, check your solutions, okay? Here we go, power series. What does a power series mean? It's got to have an X in it, okay? And in particular, we want to be very good at the geometric series, okay? A particularly important skill to develop for the AP exam, other than checking that you're in radian mode, is to represent certain types of rational functions as a geometric series. So rather than producing these using Taylor's rule, sometimes we want the shortcut, remember? So we're going to go over that here in this section. All right, suppose I told you to start with a sub 1 equals ichi. And to let your r equals 2/3, which would make it a geometric series, what would you write? We would write 1 plus. 1 times 2/3 is 2/3. 2/3 times 2/3 is 4/9. 4/9 times 2/3 would be 8/27 plus dot, 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 plus, what would that be? I could just write that as 2/3 to the n power plus dot, dot, dot. Right, there we go. There's the series. That's a geometric series. Let's keep rolling. What? I wonder why I'm asking you to do this stuff. Is it this okay? Not really, but kind of so. Let's do this next one. What if it was negative right there? Ooh, remember, I apologize. It did ask what the sum would be, which would be s equal to the first term over 1 minus the common ratio, which would be 2/3. So that'd be 1 over 1/3, which would be 3, right? All right, here we go. Let's do the next bad boy. It's got a negative ratio there. So if we had the first term of 1 ichi, multiply that by negative 2/3, multiply that by negative 2/3, multiply that by negative 2/3, right? Kind of similar to the one we had before, but it's alternating. So how would I handle this guy? Well, I could just do that, right? Or some of you might say, hey, well, couldn't you have like put an alternator in it? Faux show. Ooh, oh yeah. 2/3 to the n. I would start at 0 in that situation, right? Plus dot, dot, dot. So you could have used either of those, okay, class? All right, why am I, well, let's sum it up, right? It asked me to sum s equals 1 over, remember, if it's negative, it'd be 1 minus a negative 2/3, which 2 negatives makes a positive. That'd be 1 over 5/3, which if I added them all up would be 3/5. Remember, the only way we can find out what it converges to when a series converges is the geometric series. Okay, now why are we doing all this stuff? Well, what happens if we have an X in it? And we all know that it has to have an X in it to be a power series. All right, whoever does that in class might get bonus, right? It's like a new move that could block power series. All right. So first term, 1. Let's multiply that bad boy by x. X times 1 is x. What's x times x? Well, that's x squared. What's that times x? Well, that's x third. X to the third plus that, plus, what's the general term? X to the n plus that, right? And then what if I asked you what it summed up to be? Well, you would say s is equal to 1 over 1 minus the common ratio. Oh, snappy-dap. That looks familiar. Remember, we did that last class, right? And that's a Taylor series that we have the little formula for, right, class? So you know what's interesting is this is a form of a geometric series. And we're going to use that now to make some of these problems much easier to deal with, okay? Example 2, I'll show you how. Verify your answer from 1C by finding the power series. Now, we already did this, right? We did that last video, okay? Now, what we didn't do is by using long division. So let me show you how we would do this using long division, right? Going long division old school, you divide 1 with 1. And if I divide 1 by 1, I get ichi. Okay, and then remember, you multiply 1 minus x. And then remember from earlier this year, then you do the most important step, which is you subtract it, which is changing the signs, which gives me x. And then I do x divided by 1, right? That's my next term. And then I multiply and I get x minus x squared. But then we have to remember to subtract or change the signs, x squared. Kind of see what's going on, don't you? And then we do x squared divided by 1, which is x squared. Multiply that, I get x squared minus x to the third. Most important step, subtract, which is change the signs, x to the third. You get what I'm getting after. Booyah. Now, every problem we do today, since we've kind of gotten good at the radius and interval of convergence, you are going to do, okay? And I will always give you the answer. This interval of convergence is -1, 1. Make sure you are doing that in your notes. So the smartest thing right now would do to hit that pause button, get that work done, and make sure you verify it's -1 to 1 and verify those endpoints, okay? And use, if it's x to the n, go crazy. That could be a ratio test, that could be a root test, that could be a geometric series test. Okay, use any of those you'd like. Make sure you test those endpoints, okay? And I gave you the answers to what they are, but please make sure you are doing it. Maybe I'll ask you next class. All right, now what's the point of all this we're doing here? Well, now we're dealing with a power series that I don't have memorized, which is 1 over 1 plus x. And the question is could I finagle that dude into something I know? Believe it or not, I could. Okay, and it's asking me to find that power series. So one thing I could do is is this legit? Is this legit? What if I did this? 100, that's legit, right, class? So I'm going to use this power series, right? And this is a very easy one for us to memorize, plus dot, 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 plus x to the n. And we're going to use this guy, plus dot, dot, dot. And we're going to use this, why? It's geometric. Well, if it's geometric and we've got that guy, okay. I could go ahead and, what's it say? List the first 4 non-zero terms. Let's write them out. All I have to do, right? Same form. Just put a -x wherever I see an x. So we're 1 minus x. It's going to be -x squared, which would be plus x squared. And then it would be x to the third. If I put a negative in there, it would be -x to the third. Plus dot, 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 plus, and then I could just put a -x in there, and there we go. Donezo, right? And if I wanted to write it like it had an alternator, I could do a little -1 to the n times x to the n, right? Do whatever floats your boat, or whatever makes your problem easier to deal with. Now, guess what this problem asked me to do after I do that? Well, I wrote the first 4. I have the general term, right? I have the general term written 2 ways. And then find the interval of convergence. Now your interval of convergence for this problem, I'm just not doing it because we've been doing these guys like crazy, is that, remember, your best bet to get really good at this section in the ASAP BC exam with the 5 is to make sure you hit pause and you do that right now, okay? But if not, we're going to keep rolling and we're going to do the new stuff that's introduced in this section, okay? If it gets to any tough interval of convergences, we'll do them together. All right. So now we have this power series centered at 0. Ooh, Maclaurin, maybe I can use that cheat, right? First 4 non-zero and the general term. So once again, it does. Kind of looks like that bad boy, which is this, right? Plus that, plus x to the n. Always should write it out. Now, how could I make this look the same? How could I bring this guy up in this problem? Well, I'm going to take that x out, right? And then it'd be just what we did last one, right, class? That's it. So I'm going to just do this one at a time. I'm going to keep the x out there, but then I'm going to rewrite, this little term right here. First 4 terms, let's go ahead and do, because that's what it says. It'd be 1, but I have to put a -x in there, so it'd be, and we just did this, right, class? Minus x to the third, right, plus ta-da. Okay, I'm not going to worry about the general term yet, because now I have to distribute an x in there, right, class? Actually, for sure I should worry about that. It'd be x to the n, -x to the n, right? Plus da-da-da. Okay, now let's multiply everything by x. All right, and we go x minus x squared plus x to the third minus x to the fourth, right? That's just, and then remember, I said for the general term, we could take out that alternator, correct, class? And then I would have x to the n times x to the first. Now, what's x to the n times x to the first, right? X to the n times x to the first. Oh, snap, I just went out. What the what? Let me pause this. Whew, back at you. You didn't see that, but well, you probably saw it. My screen went a little black there. All right, blue. And that I could write that as x to the n plus 1 plus da-da-da. Okay, so there's my general term. There's my first 4 terms. What's your job right now? Your job is to hit pause. And guess what the interval of convergence is? It is -1, 1. Make sure you hit pause and you can figure that bad boy out. Okay? Let's keep going. This video might not be too bad. All right. Here we go. Here's my new guy. All right. Oh, snap. Oh, snap. Well, awesome. It ran out on our new example. I didn't even get interrupted, so all I got to do is hit, pause, and unpause. and I'm right back with you. All right, here we go. I got my new screen, got my new pen, right? And we've got this problem here now. Okay, that kind of very much looks like 1 over 1 minus x, right? You'll probably get sick of this, but you know what? The more times I write it down, I'm never, ever going to forget it. All right, well, that's just plugging an x squared in, right? So that shouldn't be too bad. All right, so that's just 1 plus x squared plus x squared squared plus, let me do one more just so I get the hang of this, x squared to the third plus da da da. And then believe it or not, you just have to go with a little plus x squared to the n, which would be equal to x to the 2n, writing it nice, plus da da da, right? There we go. 1, 2, 3, 4. General term was your job. Your job is to find the interval of convergence. Take a guess. Negative ichi. Okay, hit that pause button. Go ahead and check it. If not, we'll keep on rolling so you're not staying up too late, and you can work on those worksheets to make sure you have those other worksheets down pat. When you replace x with a multiple of x, beware a change in the radius or interval of convergence. For real? Okay, there's got a little hint there. But that definitely looks like 1 over 1 minus x, which is 1 plus x squared. I know you got it. Plus x to the n plus da da da. Okay, the more right times you write it down, you're just going to have that bad boy memorized. All right, so what do I do here? Well, this time I'm replacing it by a 2x. Well, what happens? Well, guess what? When you do the interval of convergence, you better check some stuff. Okay, let's see what we get here. We get 1 plus. All right, I got a 2x right there, right, class? Plus. Then we have a 2x squared plus. Then we have a 2x cubed, right? And you could do some simplifying with those first terms. Plus da da da. What's the general term? Well, it's just 2x to the n plus da da da. Okay. Now, since they said something might be a little bit different, why don't we kind of handle this bad boy together? Well, if this is what this bad boy is equal to, right, 2x to the n, I would probably just do the root test, right? Root test would be a piece of cake for this one. You could do the ratio if you'd like, but this is, remember what the root test says. Absolute value, but it's got to be able to raise to just the n, and it'd be 2x to the n. Those guys go away. Remember, it's got to be less than 1 in order to converge. So you will get the absolute value of 2x is less than 1. So what's my ratio? What's my radius of convergence? It would be 1/2. So you guys make sure you hit that pause button, because now you have to check the endpoints. And guess what I get as my answer? Booyah, booyah. Go ahead and hit that pause and check it. All right. And what I really like for you guys to do, you know, you're probably like, Mr. Tanaka, you are boring me out. These problems are all the same, right? They're not too bad. That's how important this result is of 1 minus 1 minus x. Now, this guy, I don't know. It kind of does, believe it or not, right? It kind of does. But how the heck do I make it look like it, right? And since we remember, if you remember going back to those AB days, you know, we had those inverse trigs that we had to like finagle and move them around so it would work out. And that's what we kind of have to do here. If you remember when we did those guys, right? The one thing we needed to do is we needed to have an ichi right there. That's kind of first and foremost, right? So this one's kind of tougher, but to do this one, let's go ahead and rewrite this problem. Okay, and I'm going to take out that 4. If I take out that 4, I get 1 plus x over 4. And believe it or not, if I write it like this now, that's all I kind of really have to do. Because to get that minus, I could just go minus and then a negative x over 4. Right, class? That's not too bad. But I am going to have that 1/4 out there on the outside, right? And then what am I going to do? Well, then I use my little rule up there. What's my rule say? Well, it's going to be 1 plus, in this case, it would be a negative x over 4, right? And then it would be plus x over 4, actually a negative x over 4 squared. And then it was going to be a plus, which actually would end up being a negative, right? So it's kind of like I've got an alternator going on here, but I could distribute that 1/4 into each one of those guys, correct? But I would go plus dot, 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 and this would be plus negative x over 4 to the n, plus dot, dot, dot. obviously a lot of different things I could do, right, class, if I wanted to write this in different terms, right? Technically, I should multiply that 1/4 into everything. And if I did that, I would get 1/4 minus x over 4 squared. Okay. Let's go ahead and simplify this a little bit. That would be plus x squared over 4 to the third. Oh, we're kind of going up by ones there, huh? And then it would be negative. What would that be? That'd be x to the third over 4 to the fourth plus dot, dot, dot. Plus, okay, I got an alternator. Let's take care of that bad boy. So that'd be negative 1 to the n. There's my first 4 terms. My x's are going up, x to the n. We got that guy taken care of. And then what do we have here? We have a 4 to the, well, if I go 4 to the n, that would be bad because we're going to start with putting a 0 in there, right? So let's start with a 4 to the n plus ichi, right? How about it? That guy works out plus dot, dot, dot. All right, now that's not too bad. That would be a, yeah, you actually could do a little bit of a root test with that bad boy. Ratio test works with that bad boy. Make sure you do it. If you do it, you should get negative 4, 4 as your interval of convergence. Okay, we've done problems way tougher than that in class. So hopefully you are okay finishing that on your own. Guess what, class? I got one more. And I can't see my time on this clock, but I've got to imagine that it has not been too bad. All right, here's our last one. All right, definitely can't use a cheat for this bad boy, okay, because it's just 1 over x. Oh, and we're centering it at 1. So what a great worksheet. This is bringing us back to our roots where we got to use Taylor's rule. Okay, let's go ahead and do it, right? So we got f of x is equal to x to the negative 1. That would mean f of 1 equals ichi. Okay, so then let's do f prime. And how far do I have to go? First 4 non-zero. So that means I'll have to go to the third derivative. Okay, that's negative x to the negative 2. F prime of ichi equals negative 1. We got f double prime of x, a second derivative. That'd be 2x to the negative 3. And that'd be f double prime of ichi. Ooh, no, positive ichi equals 2. And then we got the third derivative, right, of x, which would be negative 6x to the negative 4. And the third derivative evaluated at 1 would be negative 6. All right, let's write down these first 4, which would be ichi minus 1 x minus 1 to the first over 1 factorial plus 2 x minus 1 squared over 2 factorial. Remember, we're finding out, don't simplify until maybe you see that a pattern is going on, okay? Plus, what do we have? Ooh, not plus, minus 6 x minus 1 to the third over 3 factorial. All right, I see the pattern, plus da, da, da. All right, so let's go ahead and simplify. Okay, 1 minus x minus 1 plus x minus 1 squared minus x minus 1 to the third plus dot, 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 plus the general term would be just, ooh, we have an alternator. Ooh, I remember we don't usually put the n there until we make sure the alternator is covered to the end. Good to go, right? Because we're going up by ones. If we start out with 0, it's going to be a positive 1. It alternates monies. Okay, so there's the first 4. There's the general term. What is your job to do? Find the radius in the interval of convergence. I did that already, a little bit different this time. So make sure you are doing it. If you are struggling with any of those radius or interval of convergences, then please make sure you come in for some help. Believe it or not, that is section 9.4, part 1. Please make sure you're done with your 9.1, 9.2, 9.3 worksheets, okay? And make sure you work on those interval of convergences. Aloha!